Hello all. I wanted to make a quick video to cover part of homework 6 that I'm not going to be able to cover in class. Um, these two pieces you actually won't be tested over, but it might show up in a future class. So I do want you to have exposure to what these graphs look like. So we want to graph the cosecant of x and the secant of x. Again, we just won't have class time for this. On Friday, we're going to graph tangent and cotangent and transform them. So cosecant and secant, you won't be tested over these, but I do want to go through how to find these. Okay, so let's start with cosecant. So I just want to make a note here. This is the reciprocal function of the sine. Y equals the sine of x. That means the cosecant values are going to be the reciprocal of your sine values. You can do an XY chart here because I mainly just want you to see the graph and be familiar with this. I'm kind of going to use the basic form of our sine graph and use that to help us. So I'm going to fill in a sine graph here real quick. And then eventually I'm going to erase it, but it's going to help us with the cosecant. So get my landmarks here. And then the sine graph starts at 0, comes up to the top at 1, comes back to the baseline, comes down to the bottom at -1, and then back to the baseline. So this is what the sine function looks like. Okay. All right, so we're going to use that to help us get some cosecant values quickly. Okay, so when x equals 0, the y value of our sine function is 0, or 0 over 1, which means that when x is 0, the cosecant value is going to be the reciprocal of that. The reciprocal of 0 over 1 is 1 over 0. What's 1 divided by 0? Well, that's undefined. That is not a number. So what that means is that on the graph of cosecant, there is not going to be a y value when x equals 0. This is actually going to be a vertical asymptote. Cosecant has a vertical asymptote at x equals 0. Okay, so let's keep going here. At pi over 2, my y value is 1, which means the cosecant value is going to be the reciprocal of that, which is the reciprocal of 1 is 1. So my cosecant is actually going to have the same value of sine there. Okay, let's come to pi. At x equals pi, the sine of pi is 0, which means the cosecant of pi is going to be the reciprocal of that. Again, 0 is 0 over 1. The reciprocal of that is 1 over 0. This again is undefined, which means we're going to have a vertical asymptote at x equals pi as well. Interesting. Let's keep going. At x equals 3 pi over 2, the sine value is -1. That's -1 over 1, which means the cosecant value is going to be the reciprocal of that. That's 1 divided by -1. That's still -1. The cosecant value is going to be the same there. And then at 2 pi, the sine of 2 pi is 0, which means the cosecant of 2 pi is going to be 1 over 0. Again, the reciprocal of 0 over 1. That's undefined again, which means we are going to have a vertical asymptote there. Now, you can pick a few more values if you want, but basically what's going to happen is that the graph of cosecant is going to start at these points, and is going to open up to your asymptotes. And here from -1, it's going to open down to your asymptotes. And then if we kept going here at 5 pi over 2, this is coterminal with pi over 2, which means we're going to be up at 1 again. At 3 pi, that's going to be coterminal with pi, which means we're going to be undefined there. At 7 pi over 2, that's coterminal with 3 pi over 2. I'm going to be down at -1 again. And then at 4 pi, that's going to be coterminal with 2 pi. I'm going to be undefined again there. And I'm going to open up to our asymptotes and down to our asymptotes again. So basically, we're repeating this pattern of going up and then down and then up and then down. And that's going to go in both directions. So negative pi over 2, we're going to be at -1. And we're going to open down. And we'll just keep going. So this one would open up and then it would open down and it would just keep going like this. So this blue one is what the graph of y equals cosecant of x looks like. I'll go ahead and just remove that dotted one just because I don't know if that's confusing you more than anything else, or if it's helpful to have it in there, that's totally up to you. But I'll just get rid of it now for the time being. But this is what the cosecant graph on its own looks like. Okay, so what's the domain of this function? What x values are covered by this? Well, all of them except where our vertical asymptotes are. And our vertical asymptotes happen at negative pi and 0 and pi and 2 pi and 3 pi and 4 pi. It happens at the multiples of pi. And so our domain is basically x can be anything except negative pi, 0, pi, 2 pi, and so forth. It's basically everything except multiples of pi. And that's kind of hard to write because this is going to go on forever, which is why we kind of do this dot, dot, dot at the end of each of these. It kind of indicates that the pattern continues on forever in both directions. And so that's kind of the easiest way to do the domain of this because we're going to have an infinite number of intervals. And so it's just easier to do it this way. Okay, and then what's the range of this function? The y values that are covered here are actually the opposite of the range of sine and cosine. Everything is covered except for between -1 and 1. So our range is going to be from -infinity to -1 and from 1 to infinity, but nothing in between -1 and 1. And we're including -1 and 1 here because these points that sine and cosecant share cover -1 and 1. So we want to include those. All right, the period. What's the period of this function? How long does it take to repeat itself? Well, let's see. This starts at 0, and then we go up, and then we go down. Oh, here, now we start going up again. So from start to finish, our period here is 2 pi. It has the same period as the sine function. And then the location of our vertical asymptotes, that's going to be x equals your multiples of pi. Basically, those are the excluded values from our domain. So we'll kind of represent those in similar ways. So we'll just say the location of the vertical asymptotes are x equals our multiples of pi. All right, so that's the cosecant function. Let's see what the secant function looks like. So again, we'll do it this way. And I think it's helpful. Secant is the reciprocal function of cosine. So let's start with graphing cosine the same way that we did with the sine, and I think that will help us. So we got pi over 2, pi, 3 pi over 2, and 2 pi, and 1 and -1. Those are all of our landmarks. Cosine starts up high at 1, comes to the baseline, drops down to the bottom, comes back to the baseline, and ends back up at the top of your function. And so I'll dot that in. That's what the cosine function looks like. So now let's use that to help us graph the secant function, which is the reciprocal of this. Okay, so when x equals 0, the cosine of 0 is 1, which means that the secant of 0 is the reciprocal of that, which is still 1. Okay, at pi over 2, the cosine of pi over 2 is 0. That's 0 over 1, which means the secant of pi over 2 is the reciprocal of that. That is 1 divided by 0. This is undefined, which means we are going to have a vertical asymptote here. If x equals pi, the cosine of pi is -1, which means the secant of pi is the reciprocal of -1. The reciprocal of -1 over 1 is 1 over -1, which is still -1. At x equals 3 pi over 2, the cosine of 3 pi over 2 is 0, which means the secant of 3 pi over 2 is the reciprocal of 0, which is 1 over 0. That's undefined. I can't divide by 0, which means we have a vertical asymptote here. And then at 2 pi, the cosine of 2 pi is 1, which means the secant of 2 pi is going to be the reciprocal of 1, which is still 1. And again, this function is going to open from these points up to our asymptotes and down to our asymptotes. So this is what the secant function looks like. And again, this pattern is going to continue. So 5 pi over 2, this is coterminal with pi over 2, which means I'm going to have a vertical asymptote there, which is going to fill in this side of that, kind of that bowl shape up here. And then at 3 pi, that's coterminal with pi, which means I'm going to be -1 here. And this is going to be 7 pi over 2, which is coterminal with 3 pi over 2. So I'm going to be undefined there again. And I'm going to open from here down to my asymptotes. And this pattern will continue on in both directions. And again, we would open, so, sorry, got a little higher than I wanted to there. So open down here. This pattern of opening up and then down and then up and then down, again, will repeat forever. So this is what the graph of secant looks like. Just going to kind of get rid of some of that dotted line so you can see the secant function on its own. So that's what secant looks like. What's the domain of this function? What can x be? Well, it's anything except for these places where my asymptotes are. So basically our domain is everything except, and again, I'm going to do a dot, dot, dot to say this is going to continue forever, but I'm going to establish a pattern so we can see that. So it's going to be x can be anything except negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, et cetera, in both directions. And then what's the range of this function? What y values are covered? Well, that's the same as my cosecant function from above. So that was negative infinity to negative 1. And I'm going to union that with 1 to infinity. It's everything except the values between negative 1 and 1. And the period of this thing, how long does this take to repeat itself? Well, if I start here at 0, I come up to my asymptote, I go down to my asymptotes, and then here I get the left side going up to my asymptotes. Here is kind of where we start repeating itself. This one has the right part of that, and this is the right part of that. So 2 pi is kind of the end of the line. And again, my period here is 2 pi. From start to finish, it's 2 pi. And then the location of my vertical asymptotes, these are x equals, the way that we'll do this is it's going to be the odd multiples of pi over 2. And it's only the odd multiples because if I took pi over 2 and multiply by an even number, say pi over 2 times 2, that becomes 2 pi over 2, which is pi. And I don't have an asymptote at pi. So that's why it's the odd multiples, because it's only the places where I multiply pi over 2 by an odd number. Okay, so the vertical asymptotes happen at the odd multiples of pi over 2. And these are the graphs of cosecant and secant. You may be asked to be familiar with these in another class. So I wanted you to be able to be familiar with these. You won't be tested over this in pre-calculus, but I wanted you to see it. So I hope you enjoyed this and have a great day.